Academy. Today we'll continue with our applied electricity tutorial series. Today we'll be looking at self-assessment 1, and with this self-assessment 1, this video will test your understanding on equivalent resistance, current division rule, Kirchhoff's current law, and Kirchhoff's voltage law with this self-assessment 1. So this quiz style video will help you assess how well you really understand the fundamental concepts in circuit analysis. Make sure to attempt all the questions and drop your answers in the comment section so that we really know whether you are really following or not. And the topics that will be covered in this video are equivalent resistors, that is resistors in series and resistors in parallel, the current division rule, and the Kirchhoff's current law, and finally Kirchhoff's voltage law. So I will encourage you to challenge yourself and see how much you have learned. So if I post every question that before I start working every question, pause the video and try solving it on your own before coming back to watch the solution. It will really go a long way to really help you to know whether you are really prepared for your midterm or your exams. But in case since there's no midterm for now, it will really tell you how well you are prepared. Don't forget to like, share, subscribe for more tutorials and assessments. And don't also forget to turn on the notification bells so you don't miss our next lesson. So kindly stay tuned as we dive into our questions. Thank you. Okay. Oh, our question 1 says, what is the total resistance in the circuit? What is the total resistance and current in the circuit below? All resistances are in ohms. And we realize that this is our circuit they've given to us. So I will solve this circuit in 2 ways. I will use a simulation to show you, and I will finally use our normal step by step to show you. When we look at this circuit, let's first of all use the simulation. Realize that there is a short circuit here. So when this current gets to this node, it doesn't split. All the current will just take this path and come back, because meaning this 2 ohm resistor, this 2 ohm resistor, and this 2 and 2 have been short circuited. So let me take the simulation for you to really appreciate what I'm saying. So looking at our simulation, realize that see, when the current starts from here, just passes through this and comes back. So that means the rest of the circuits have been short circuited. The rest of the resistors have been short circuited. So we'll now take them out of the circuit if we want to perform an analysis. Then we'll redraw our circuit. So our new circuit now becomes this. So we simply have our voltage source and our one resistor, meaning we only have one resistor, and they said that we should find the total resistance. So simply to find the total resistance in this circuit is 5. So we say to find our total resistance, our RT is 5 ohms. I forgot to bring the units, please. The units are important. 5 ohms. So finally we can just say our RT is equals to 5 ohms. And now they said we should also find the total current, and we know from Ohm's law V is equals to IR. And since V is equals to IR, we can find our total current in the circuit. Obviously our total current in the circuit is equals to our 10 over 5. So it's equals to V over the total resistance, which is 10 over 5 is equals to 2 amps. So our final answer for our total current is 2 amps. So please, you realize that always take time, check whether there is a short circuit or not. So moving to our next question. So in our next question, they said find the total resistance and current in the circuit below. All resistances are in ohms. So the same thing here. I'll also solve this question with a simulation, and we'll solve it in the normal way. But first of all, let's look at this. When current starts to flow from here, it gets to this place, it splits. But what do you realize? You realize that these 2 and these 2 are in series. So we simply add these 2 and these 2 to get 4. And these 2 and this 4 are also in series. So we simply add these 2 and this 4 to get 6. So looking at our simulation, you see that a guess here, this one and this one are in series, this one and this one are in series. So I redraw my circuit. After adding them up, I get my 4 here and my 6 here. So you see that realize that this 6 and 4 are in parallel, because when the current gets here, it splits. It splitted and some came to the right, some came to the left. So these two are in parallel. Then I resolve them. After resolving them, I realize that after resolving the 4 and 6 in parallel, I realize that it's also in series with the 1. Then I can see the 1 and the 2.4 are in series because the same current flows through them. So finding our total resistance, we realize that the 1 plus 2.4, that is the 1 plus 2.4 here, is equals to 3.4 ohms. And to find our total current, so those of you, I know everyone knows how to find parallel. So since we were finding the 4 and 6 in parallel, it was 4 times 6 over 4 plus 6. Then we get our answer as 2.4. That is why here, that's why we are having our 2.4 here. So the circuit now becomes shorter. Then we apply our Ohm's law to find our current. Total current is equals to the voltage over the total resistance, which is 3.4, and our answer we get is 2.94 ohms. So this is how we solve the question. So basically, you have to first of all identify resistors in series, add them up, resistors in parallel, you add them up, find the total resistance, that is the RT, then we find our total current. So that is how we solve it. Moving on to our next question. With our next question, it says find the current I in the circuit below. So to find the current I, this is a 20 amp. This is the total current entering 20 amps, and you realize that when it gets to this node, it's placed, some comes here, some comes here, and some comes here, and they've named here I, and they are telling us that we should find the current I. So to find the current I will solve it in 2 ways, as I really want you to appreciate this course. It's very simple. So in solving it in 2 ways, I'm going to use the simulation and the hand method. So with the simulation, this is our simulation here. So realize that you see our 20 amp here, and this is our, you see the current passing through here is, when you check the details here, the current passing through is 5.71, and the current passing through, the current that is passing through this branch is 14.286, but the current passing through I is 11.29. So the simulation has told us the current already, but now it is now left it onto us to find out, and the current passing through this 4 ohm resistor is 2.85. So it's now left for us to now find our total the current here. So to find the current here, what do? We simply add, to apply the current division rule. We know that it's always 2 resistors in parallel. We consider 2 resistors first. So the current division rule can consider 2 resistors first. So we combine this and this. So combining the 1, we realize that 1 and 4 are in parallel. So we combine them and redraw our circuit. So realize that 1 and 4 are in parallel. So after combining them, we have to redraw our circuit as this. Then we have our 20 here, our 20 amp here, and we have 2 here, and we have our 0.8 here. So let's name the current coming here I2, and we need to find I2 because when we come back here, we realize that this current, the current that is coming here, the current we named it I2, is the one that was split between this I and this 4. Realize that this current, let me name it here, I2. Realize that I2 here will split when it gets to this node. It will split between this 1 ohm resistor and this 4 ohm resistor. That's why I just named here I2. So to find I2, we have to apply the current division rule. The current division rule says I2 is the current passing through the 0.8 ohm resistor. So it says the opposite resistor and the opposite. So the opposite to this one is 2. So it will become 2 divided by 2 plus 0.8. So doing that, we get I2 as multiplied by our 20. 2 divided by 0, that is 0.8 is also known as 4 over 5, plus 2 times the 20 amps, the total current. Then we come and get 100 over 7 amp. After getting our 100 over 7 amp, we come. So we now know the value of I2. I2 becomes 100 over 7 amp. So here we can say, can come and write is equals to 100 over 7 here. So we realize that I2 here gets to this place and is placed between this and this. So we now find our I. We can simply now find our I. So we find the opposite resistor. So our total current now becomes 100 over 7. So the opposite resistor to I becomes 4 all over 4 plus 1, then times our 100 by 7. So this is what we do. So since we are finding the current through this, we take the opposite, which is 4, all over for the sum of the resistors, 1 plus 4, times our total current, which we just found, 100 over 7, which gives us 80 over 7. And we realize that the 80 over 7 is the same, when we convert it into decimal, is the same as what we got here. So that is how to use our simulation and the our normal method to find the current between a resistor. So moving on forward, we take our next question. Our next question says find Ix. So to find Ix here, we also have to use our current division rule. So as I've been doing from our previous questions, I'll use the simulations to solve this, and I'll also finally now use our hand method to also solve it. So using the simulation, we realize that we are finding the current Ix. So the current through this 8 ohm resistor is 6, and the current through this 4 ohm resistor is also 6. And here the current that they said we should find is 3, because when they came here it was 3. So it will come back again. So the current through the 8 ohm, this 8 ohm resistor, we need to find is 3. But the only difference is that you see the arrow is pointing upwards. The arrow is pointing upwards, so we have to take note of that. It's pointing in the negative direction. So whatever answer we are getting, we have to negate it. We have to negate the formula. So applying this as normal, we know that we have to combine these two resistors. This and this are in parallel and in series with this 4. So after combining them, the two of them, 8 and 8 are in parallel and in series with 4. So that is 8 times 8 plus, this is a mistake, so it's 8 times 8 all over 8 plus 8 plus 4, which is equals to 8 ohms. So after getting our 8 ohms, we realize that we have to redraw our circuit. So let's name the current coming through this one too as I2. So after redrawing our circuit here, we have our 8 here, then we named here I2, then we have our 12 amps coming here, and we also have 8 here. But we realize that we have to calculate I2. We have to calculate I2. That is, I2 here is placed between this Ix and this 8. This is placed between this and this. So to calculate for I2 is simply the opposite resistor, and since they are the same, it's just the opposite to I2 is 8. 8 over 8 plus 8 times 12. So doing that, we get our I2 as 6 amps. So if we get our I2 as 6 amps, we now come back. We now know that I2 is 6 amps. Then we now come back to this circuit. So coming back to this circuit, we now know that I2 is 6 amps. So I2 split between this branch and this branch. So we also apply the current division rule here, but now the total current now becomes 6 amps. So coming back here, we find Ix, but Ix is going against the direction of our current, so it becomes negative. So our formula now becomes this. So minus 8 all over 8 plus 8 times 6. That is it, because I2. This 8 all over the sum of the resistors times 6. So we get our total current as minus 3 amps. So that is how to use the simulation and how to use our normal hand method to solve our current division rule problems. Let's move to our next question. I hope you guys are following, and if you are having any issues, you can just kindly leave a comment so that we'll know where you are having issues. So moving to our fifth question. Our fifth question said we should find the total current and the voltage drop in the circuit below. Finding the total current and voltage drop in this circuit. What do we realize? First of all, realize that they've given us this current. This 500 milliamps simply means 0.5 amps. So milli is 10 times 10 raised to the power minus 3. But what do we realize? Realize that the 5 and 2 are in parallel. So when we realize from the current division rule, now they've given us the current. They've not given us our total current, but they've given us the current in this branch. They've given us, let's name them. So let's say we were naming here, this was I1, and here this is I2. But I1 is here is cost 0.5 because they've given it to us. So if we now want to find it, we have to apply the current division rule. So if we wanted to find the current in this branch, we would have taken 2 divided by 2 plus 5 times the total current is equals to I1. But now we know the value of I1 as 0.5, so we can write it as this. So apply the current divider rule to find that. So write it as 0.5 is equals to the opposite resistor 2 all over 5 plus 2 times our total current. So since this one, we simply do our normal mathematics to find IT. So IT is the total current now flowing through the whole of this circuit is 1.75 amps. After we found this, the next stage is to now find the voltage drop across R1. To find the voltage drop across R1, I will advise that we need to now combine this resistor and this resistor. They are in parallel. So let's combine them to become one resistor. So it now becomes this. After combining them to become one resistor, we now have a new resistance of 10 over 7. So 10 over 7, and our IT flowing through it, our IT is equals to 1.75. So taking the loop in the clockwise direction, we can write a loop equation. We can write a KVL equation. So writing our KVL equation, we will see that we want to find the voltage drop. So this one will become 10 is equals to the current multiplied by the voltage, the resistance here, it becomes the voltage drop, plus our total current multiplied by our voltage drop here, which is R1. So doing this, we get this equation. We come and get this equation. After getting this equation, what is now left is mathematics. So we simply do our multiplication and addition and division to simply find the value of R1. Finding R1, we realize that R1 is equals to 30 over 7 ohm. So getting our R to be equals to R1 to be equals to 30 over 7 ohm. We now need to find the voltage drop. How do we find the voltage drop? And we remember that the voltage Ohm's laws is equals to V is equals to IR. So it's simply the voltage drop across this resistor is simply the total current multiplied by the total resistance. So since we now know the value of the total resistance, we simply just change it into our formula. Then IT times R1 is equals to 1.75 times 30 over 7, which is equals to our 7.5 volts. So we can say the voltage drop, which we call it, let's say V1, across resistor 1 is equals to 7.5 volts. So this is how we solve this question. You might see it to be tricky, but it's just simple. This one, usually with current division, they will give you the total current and they will ask you to find the other currents. But now they've given you one current here, and you are now using that current. You use that current to find the total current in the circuit, and now you can now even use it to find the voltage drop across a resistor. So basically, this is how we find questions here. And moving on to our next question. Our next question says, find I1 and I2 in the circuit. I know from our video so far, you see that from our questions, we solve about 5 questions so far. You see that they don't tell you to use any principle. So here you are the engineer here, you have to know the principle you have to use. If it is if it is KCL, if it is KVL, if it is current division, whatever, you have to know the approach you used here. So the question says, find I1 and I2 in the circuit below. This is our circuit. So this is our I1. They've given us the direction. This is our I2. So what I will do here, I'll first of all simulate this, use simulation to find the currents, and so that we'll finish and we'll confirm. So with our simulation, we realize that the current through this I1 is 3.2 amps. So you see here, I1 is 3.2 amps. And when he takes the cursor to, so I2 is 3.1 amp. And the last current in this branch is 1.52 amp. So you see the simulation has given us, and it has given us even the voltage drop across those resistors. So now, it's now left on to us to also use our normal solving principles, our KCL, KVL, and others to now confirm these answers. So to confirm these answers, I'll apply KCL at this node. So we'll realize that when current gets here, it splits. It will split. So here, KCL says sum of current entering is equal to sum of current leaving. So which ones are leaving? So this one, I1 is entering. I1 here is entering, and these two are leaving. So basically, this one will now become, our equation here will now become, let's name this one I3. So here will now become I1 minus I2. I hope you get it, because it's leaving. I1 minus I2 to get this, because it's this current, this I1 that split into this and this. So when we also get here, this one is entering. This one is entering this node. So, and this one is leaving the node. And here, this one will also be leaving the node. So to get the current that comes here, it will be I1 minus I2 minus I3. That is how we get the current that comes here. So the current that will pass through this one will be this. The current that will pass through this resistor will be this. And the current that will pass through this resistor will be this. And the values of these our voltages are this 60 volts and this 30 volts. So here we'll now have to apply KVL in each loop. So I'll decide in this loop, I'll decide to take the clockwise direction. This loop, I'll decide to take the anti-clockwise direction. And this loop, let's apply it one by one. So applying KVL to loop A, B, G, H, A. We realize that KVL says sum of voltage sources is equals to sum of voltage drops. So we have 30 is our voltage source, which is moving from a lower potential to a higher potential. So 30 is equals to our 4 times the whole of this I1 minus I2 minus I3. Then we come plus 16I3. So this is what I'm saying. So you see, because the reason why it's minus, I hope you understand the reason why it's minus, because we are going against the direction of this. We are going in the clockwise direction, but this one coming is minus, so it becomes minus. I hope you get it. This current, our current assignment was in minus, so, and we are taking the clockwise direction, so it becomes minus 4 I1 minus I2 minus I3 plus 16 I3. So we can simplify in this equation. It becomes 30 is equals to minus 4 I1 plus 4 I2 plus 20 I3. Here is I3, sorry, it's I3, 20 I3. And we also take our next loop. Taking our next loop, which is loop B, C, F, G, B. We realize that when we are moving in the, we take our loop in the anti-clockwise direction. So when we are moving in the anti-clockwise direction, what do we meet? We first meet minus, because this one is coming in this I2 is coming in the opposite direction, so it becomes minus 8 I2 plus 4.8 times I1 minus I2 bracket open plus 16 I3. So this is basically what I'm saying. This loop, considering this loop, we get this 4.8 I1 minus I2 plus 16 I3 minus 8 is equals to 0, because there's no any voltage source here. Since there's no voltage source, equals to 0. Then simplifying this equation, it becomes 4.8 I1 minus 12.8 I2 plus 16 I3. So it's equals to 0. Then we can now also take our last loop, which is C, D, E, F, C. So taking our last loop, C, D, E, F, C, we realize that this is we have one voltage source, and it says sum of voltage sources is equals, KVL says sum of voltage sources is equals to sum of voltage drop. So we have 60 here is equals to, we are moving in the anti-clockwise direction. 60 here is equals to 11 I1 plus 8 I2. So that becomes our equation 3. So after finding this, our 3 equations, equation 1, equation 2, and equation 3, these are our 3 equations. We now solve them simultaneously. So solving equation 1, 2, 3 simultaneously, we can use our calculator to do that. We confirm that our I1 is equals to the 3.2, our I2 is equals to 3.1 amps, and our I3 is equals to 1.5 amps. So basically, this is how we solve this. We see that this question, they didn't tell us to apply KVL or KCL. Let us take our second but question. So with our second but last question, we realize that is that what is the effective resistance of the circuit below? All resistances are in ohms. So this one I'll just do the explanations and we go. So realize that 4 and 6 are in parallel, so we resolve them. 4 and 6 are in parallel, and after resolving 4 and 6 in parallel, it is in series with 3. So 4 and 6 in parallel, you get 2.4. 4 times 6 over 4 plus 6, you get 2.4 plus 3, so it becomes 5.4. Then you redraw your circuit again to this. So after redrawing your circuit, realize that the 5.4 we just got is in parallel with this 4. So it becomes 4 times 5.4 all over 4 plus 5.4. Then we come and get another circuit again. So we've resolved this and this, so that means we can clean this part. We clean this part and we now bring the new value here, which we get 2.3. Realize that this one and this one are also in series. 1 and 2.3 are in series, so we simply add them up. After adding them up, we get 3.3 in parallel with 3.3. 3.3 they are all in parallel. So we now find our total resistance. Finding it, this is the process I explained. So finding everything, the 3.3 times the 3.3 plus 3.3 plus 3.3 gives you 1.65 ohms. So basically this is how we find our total equivalent resistance here. Let's take our last example. I know this example, most of you might have seen it. This example, it is similar to your assignment 1, but it is not the same. It is similar to your assignment 1, but it's not the same. So it says find the current in all circuits, or in all the circuit resistors below using total resistance and voltage drop. Do not use current division rule. So they've given us, they say we should find the current in all the resistors in the circuit, all the resistors. So we'll find the current here, current here, current here, current here in all the resistors, but we shouldn't use current division rule. So they've given us an omission. They said we shouldn't use current division rule, and since they said we shouldn't use current division rule, I'll first of all use our simulations to solve this our circuit. The voltage source here is 25 volts. The voltage is 25. So using our simulation, we realize that when the current starts to flow from here, the 8 ohm and the 10 ohm are short circuited. They do not receive. There's a short circuit here. You see that the current just take this path, then it comes back. So it gets here, a split, comes here, then also here split, and just take this path and come back. The 8 ohm and the 10 ohm doesn't receive any current, so we take it out of our analysis. Then our circuit now becomes this. So finding it, we realize that, you see, the current through this resistor, all the values are shown here. The current through this 1.67, the current through this 1.67. You see that this 1 and 5 are in series. So the total current, the current through the 2 ohm resistor is 7.5, and basically everything. So we need to now confirm this answers the simulation has given to us, and to confirm it, they said we should use KVL and total resistance and the concept of voltage drop. We shouldn't use what do we call it? We shouldn't use current division rule. So to start with, finding the total resistance. So to find the total resistance, we realize that this and this are in series. The 1 and 5 are in series, so we can simply add them. After adding them up, we realize that the 6, this now becomes 6. 6 and 3 are in parallel. So 6 and 3 are in parallel. After resolving them, we get 2 ohms. And after resolving the 2 ohms, the 2 ohms now comes here. We clean this and we now write 2 ohms here. And we realize that the 2 ohms and this 4 are in parallel. So we also resolve that. So after resolving that, we get 4 over 3 ohms. After getting the 4 over 3 ohms, we can now clean here. And we'll now only leave this side. So here now becomes 4 over 3. Then we realize that the 4 over 3 and the 2 are in series. So we simply add them up to get 10 over 3 ohms. So our total resistance in the circuit is 10 over 3 ohms. After finding our total resistance, we need to find our total current, and our voltage they gave us was 25 ohms. So we simply use Ohm's law. V is equals to IR, and the IT is now equals to V over RT. So it is now 25 over 10 over all over 10 divided by 3, which gives us 7.5 amps. So now it tells us that 7.5 amps flows through here, and from our simulation, if you remember, when we brought our cursor here, it was showing us that 7.5 amps. So we now need to calculate the voltage drop in this 2 ohm resistor. So to find the voltage drop is simply the total current multiplied by the 2 ohm resistor. So the total current is 7.5. So the 7.5 by times the 2, it becomes 15. So after getting our 15, we subtract it from our total current, our total voltage. So subtracting it, we realize that we have 10 volt. So meaning at this node, 10 volts leaves here. So meaning, and resistors in parallel, what did we say? We say the same voltage flows across them. So here is 10 volt, meaning here the voltage drop here, the voltage drop at this node was 15. In this resistor was 15. So at this node, meaning the voltage that will be leaving this place, so 25 minus 15 becomes 10. Voltage that will be leaving this junction is 10. So 10 will be here, 10 will be here, 10 will be here, because it's this voltage that will here, this same voltage that will appear here, this same voltage that will appear. So basically, to find the current through, we now need to now find, since we now know the voltages that are leaving here, we now know the voltages that are leaving here. So now to find the current that the various current of the various resistors. So here, let me just write it here. So we have our 10 here, our 10 here. So now to find the current, so I'll name them current through the 2 ohm resistor. So to find the current through the 2 ohm resistor is simply our 25 divided, that is the total current, because it is the total current that will flow through our 2 ohm resistor. So 25 over 10 divided by this is 7.5 amps. But the tricky part now comes here. Current through the 4 ohm resistor here, this 4 ohm resistor, you see this is the voltage across it, and the current is simply equals to voltage over resistance, and the voltage here is 10 and the resistance here is 4. So basically we just divide this, the 10 over the 4. So the current through the 4 ohm resistor is 10 divided by the resistance 4. So 10 over 4, which is 2.5 amps. And the current across the 3 ohm resistor is also 10 divided by 3. So 10 divided by 3. So current through the 3 ohm resistor is equals to 3.33 amps. And finally, the current between, we realize that this 1 and 5 are in series, so we can just add them up, because the same and what did we say? In series resistor, the same current flows through them. Series resistors, the same current flows through them. So we can simply find it. So it becomes 10 divided by, so the current through I1 and I5 is equals to 10 divided by 6. We simply add them up, so to find it. So when we divide 10 by 6, you get 1.667 amps. So basically, this is how we find resistors. We calculate resistors in the current through the various resistors. And this so far will really, these questions, I know these questions really test your understanding on all the concepts we've learned so far in class. And kindly take your time to watch this video very well. If you don't understand anything, just leave a comment, and if you have any questions, you can also feel free to contact us. So thank you very much. This video was being taught by Elijah Tega. You can reach us through this our email. This is our email, and this is the tutor's number, Elijah Tega. In case you have any questions, further questions, you need further clarification, just reach him on this number. Please don't forget to like, share, and subscribe. Your subscription will really go a long way to help the channel grow, since it's a new channel fully dedicated to helping engineers in all the courses that we find difficulty in. So kindly like, share, and subscribe. Thank you for your time. Bye.